All right, I just want to go over a few examples of simplifying expressions with rational exponents. And we'll begin with the first one here, which if you look at it, depending on what class you're taking, you may see square root of 81 and they'll say simplify it, right? And we know that square root of 81 is, 9, right? Now, another way to look at this is the equivalent expression to the square root of 81 is 81 to the 1/2 power. You may say, why? Well, because this is the square root. The root here is not stated, so it is implied that is the 2. So it's a square root, which this is a 2. Here there is no power, and so without changing 81, if we make it to the 1 power, we have the basis for 81, the radicand, power of 1, that goes in our numerator, and then the root 2. So 81 to the 1/2. These two are equivalent to each other. This is just two different ways to write it. In higher level maths, we tend to use this, and this generally is the way it's introduced in mathematics to students. So, but the answer is going to be the same. What we look at, if we don't know right away what the answer is, then we would make a factor tree, right? And we would say 81. And I'm looking for, if I'm looking at it in this way, I'm looking for two numbers or pairs of numbers that will give me 81. Here, I'm looking for the square root of 81 pairs of numbers that are multiplied together that will give me 81. So I think about it and I think, okay, what two numbers, if they're the same, will give me 81? And immediately pops into my head 9 times 9. Now that is two numbers. I can actually substitute, let me write it like this in green, 9 times 9, 1/2, or, let's see, square root 2, and we'll call this 9 times 9. Okay, now I'm just going to, right here I have 9 times 9, multiply two numbers together. And so why does this work out? Well, 9 times 9 is 9 squared, right? Square root with 2. Okay, so here we have it. And on this end, 9 squared to the 1/2 power. Okay, this is just two different styles, if you will. This is usually for lower level math classes, and this is for upper level math classes, what you see. All right, now you'll notice that here, this is a 2 and a 2, right? So this is how many groups of 2, what two numbers are multiplied by itself to give me 81? 9 times 9. My answer is 9. Okay, here, why do I get the answer of 9? Why is it that when this 2 and that 2 is the same, it becomes 9? Well, it's very simple, because when you change it to exponents, the radical, right, this gives you 1 over 2. If the root was 3, it would be 1 over 3, right? So this is 1/3, or rather 1 over 2. And what two numbers, when I multiply, give me 81? Oh, 9 times 9. So I write that as 9 squared. Using my exponent properties, right? 2 times 1/2. Okay, I can write that as 2 over 1 times 1/2, which gives me 2 over 2, which is 1. And there you have it. 9 to the 1 power, which is equal to 9. Right here and right there. Okay, now let's do another example. Now this one's interesting because it's separated by a subtraction. And using order of operations, we don't have anything here. There's no parentheses, although we could write them in. But we're going to have to figure out these powers first before we can subtract. So let's do that. Now, we have 49. We can write it like this to the 1/2 power, which means I'm looking for two numbers multiplied with each other. That'll give me 49. And here I'm looking for two numbers multiplied with each other. That will give me 4. See the 2? 2, that tells me how many numbers I'm looking for. That will give me that when I multiply them. Or I can write it like this. Square root of 49, square root of 4. This 1/2 means square 2, right? Square root. square root. Okay, so 49, I'm going to make my famous factor trees. 49, do I have two numbers that give me 49? Yeah, I do. 7 times 7, which gives me 7 squared. I'm going to write this as 7 squared to the 1/2 power. Okay? Minus. Now, what two numbers can I multiply that will give me 4? Pretty simple, right? 2 times 2. Okay, so I'm going to write 2 squared to the 1/2 power. See, we're cooking with gas now. Now here, 2 times 1/2. We can go back to this. 2 times 1/2, which will give me 2 over 2, which is 1. So that will give me 7 to the 1. Minus 2 to the 2 times 1/2 right here. 2 times 1/2. Okay, equals 2 over 2, which is 1. That's 2 over 1. Okay, and when we keep going, this will give us final answer. 7 minus 2. This is exciting stuff. Will give us, dun, 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 I'll do this in gray, 5. And there's our answer. Now, you guys, this is a very simple example, right? I mean, if you already know your square roots, you say, oh, 49, the square root of 49 is 7 times 7. That's 7, right? And if you say square root of 2, oh, that's minus 2. And my answer is 5. Yes, but this works with everything. And this is actually explaining to you what is going on and why do you get that going, right? This is for any type of number. This works for simple numbers, but this works for any type of number and for upper level maths when you're dealing with more things and you don't want to have these square roots there. You just want to work with your powers and your exponents. Okay, so example 3, moving right along. Okay, this one's a fun one because we have a coefficient and we have a variable. And it's all in parentheses to the 1/6 power. I know that this is the 6th root of all of that because that's the number in the denominator. Cool. Now I can write it up and put it as a root. It's going to be the same exact thing. Or we can just go ahead and work with it like this with it as a fraction, a fractional power. So let's go ahead and do that. We're going to look inside this parentheses. Do they all have a power? And I like to do this because I just want to remind people not to skip anything. So the 64 doesn't have a power, so I assign it a 1 because that's the number that it's not going to change the value of 64. Okay. So using one of our properties that says whenever I am taking an expression, a power to that entire expression, I can distribute and I can multiply the powers with each other. Powers can multiply with powers. Almost like distributed property back earlier in algebra courses, right? That if you have, like, for example, 2x plus 3, you just distribute it out and you get 2x plus 6. Well, here, this is just talking about the powers. So 1 over 6 times 1, 12 times 1 over 6. Okay, let's do that. When we get that, we get, let me do this, purple, 64. 1 times 1 over 6 is 1 over 6. All right, and then x, 12 times 1 over 6. Now I'm going to put this over here, right here. Okay, 12 times 1 over 6. I am going to show this clearly. 12 can be written as 12 over 1. And when I multiply this out, I get 12 divided by 6, which is 2. Okay, so this is x squared. That's already simplified. That one's done. And now we just have to work with 64, 1 over 6. I want to see if I can get rid of that fraction as an exponent. Or at least work it out. Maybe it works out evenly, maybe not. But let's see what happens. Now, if I were doing this, I mean, I know the answer, but if you're not sure, or if I'm not sure, what I do is I go straight to my trusty factor trees. And I'm going to make this in green because trees are in green. So 64, I'm going to figure out how many, I want 6 numbers that when I multiply them by each other, they will give me 64. Or something close to 64. So let's see. 64. My first instinct is to say, all right, 8 times 8 is 64. All right. I don't have 6 numbers there, so I'm going to keep going. Now, 8 is 4 times 2, 4 times 2, right? I don't have 6 numbers, but I'm getting closer. So let me keep going. 2 times 2 times 2, 2 times 2 times 2. Oh man, let me see. How many numbers do I have? 1, 2, 3, 4, 5, 6. Oh, 2 to the 6. Look at that. So now I write 2 to the 6, which is the same thing as 64, to the 1/6 power, and my x squared stays because we were able to figure that one out without having to use a factor tree. Okay, now what's 6 times 1 over 6? Well, let me do that here. 6 times 1 over 6. I write this over 1 because I don't change the value that way, and that way I don't have any confusion. 6 times 1, 1 times 6 is 6 over 6, which is 1. Right? So that gives me 2 to the 1 x squared, which is, final answer, drum roll please, 2x squared. So you can see how we work this out. What did we have to use? We had to use the distributive of multiplying the exponents. And then from there, our famous factor tree. And it does kind of look like a tree. It almost looks like a Christmas tree. Anyway, but that works. And just be careful when you're simplifying that, when you're multiplying, you know, the fractions and the whole numbers and however you multiply them together. And this is stuff from elementary school. So that's the beauty of math, right? Whatever you learned in elementary school, guess what? It's going to come and, tap you on the shoulder and say, hello, I'm here. You still have to know this. So this is simplifying expressions. Now let's see if we can do another example. Now this is going to be, we're going to move along to variables because that's what we do. Now we start with what we used to do. Well, we start with numbers and we blend numbers and variables, and then we can just use this using variables. Okay, let's take a look. We are going to use that same property that says, if I have parentheses and I have exponents, I have to distribute through the exponents, right? This times this. And I'm going to attack this in 2 pieces because it's one piece and that's another. Okay, so let's do that. X squared times 2 and y squared times 2. What do we get as our answer? X to the 4th, y to the 4th. And I'm just showing you step by step, but it's basically 2 times 2, 4. X, that's the base. X, 2 times 2, 4. Y, 2 times 2, 4. Okay, this is part of our answer. Now we're going to do this part. I highly recommend, because you need the practice, is let's make this into a fraction. Here's my base, the variable y. This number goes in the numerator, the inside power, and the root is the denominator. Now this one's really simple. What's 4 divided by 4? Y to the 1. Hey, y to the 1. And these two are multiplied. Now we use another power rule. And that power rule is x to the 4th. Do I have another x here? No. So I'm just going to copy this. Let me write x to the 4th. Now I have y to the 4th times y to the 1. Just to quickly review. Y to the 4th times y to the 1 is y times y times y times y. This one. And times y. That one. How many y's do I got? 1, 2, 3, 4, 5. Now, even though there's multiplication, it's not a, in parentheses, it's not a power to a power. This is just multiplying 2 bases, and then you add up the powers. 1, 2, 3, 4, 5. And there's my answer. And I'll do it in orange. Y to the 5. That's how you do this. Okay? Let's look at simplification number 2. Now, if you notice, these are x to the 8th, x to the 6th. They are both the 4th root. We can figure this out, right? Or what we can do is we can sort of put it all under the same root. And that would make it, that way we can simplify it some more, right, before we can continue. So let's take a look at if we make this the fourth root, x to the 8th over x to the 6th. Now let's go through our properties. When we have the same base, power, and they're in a fraction form, I can subtract the 2. X to the 8 minus 6. That's another way to write this. We move this one up, x to the 8 minus 6. And actually, let me just explain that a little further. The fourth root, this is x to the 8th times x to the negative 6, which is the same as x to the 8 minus 6. And we get the fourth root of x squared. Or we can write that as x to the 2 over 4, which we can also write as x to the 1/2. But I want you to realize is when you have the same base and they have the same root, you can actually put it all under one large root, simplify it a little bit, and it makes life a little bit easier. So we actually get x to the, when we subtract these two, because there are ones in the numerator and ones in the denominator, 8 minus 6, we get 2x squared to the fourth root. We can leave it like this. We can write it as 2 over 4. And if the beauty of this, it helps you realize that x 2 over 4 is the same thing as x to the 1/2 power, which, by the way, is the same thing as the square root of x. So this, and this are all equivalent to each other. And obviously, when we're doing math, we want to keep it as simple as possible. So they're all correct, but this is probably your best answer, or this, depending on what you're doing. But you can see that, what's the takeaway? When you have the same base and the same root, put it all together under one radical, simplify it as best you can, and then work from it there. Okay, now let's look at our third example on this page. And this is the cubed root of 27x cubed, in parentheses, to the 4th power. The first thing I'm going to do is I'm going to simplify it. Similar to what I did is I'm going to try and make this part on the inside. I'm going to put it all together and try to make it easier to deal with, or simplify it a little bit. And by that, I am going to be multiplying 4 times to the 1 power and 3 times 4. That's going to give me, okay, 27 to the 4th power and x to the 12th power. Now I am going to get rid of this cubed root in this form. I am going to write it as, I'm going to write this as, let's see, 27, 4 to the 3rd times x, 12 to the 3rd. Okay, so let's take a look. Okay, we are basically saying x to the 12 divided by 3 is x to the 4th. That's simple enough. Okay, we found our x to the 4th. Now this 27 is a little more complex. Let's see how this plays out. I'm going to do this in red. 27 4/3. Now, this basically means 27 multiplied by itself 4 times, right? So this is basically 27 4/3. I am going to look to change the 27, and I want to break this down into hopefully a group of 3 numbers that can be multiplied by themselves. That'll give me 27. So let me take out my magical tree. Okay, and I'm going to put this right here. 27. What times what gives me 27? And that is 3 times 9. I don't have 3 numbers. Let me keep going. What times what is 9? 3 times 3. And I bring down this 3. I have 3 numbers. That is 3 to the 3rd. I'm going to change my 27 to the number 3 to the 3rd. 3 to the 3rd, 4/3, and x to the 4th. All right, well, let's multiply this now. Here's my 27, right? 3 times 4/3, because I'm taking power to a power, and I multiply them. Okay, 3, 3 over 1 times 4/3. And x to the 4th. Well, when I do that, 12 divided by 3. 12 divided by 3. Oops, that's kind of getting messy. Let me write that up here. 12 divided by 3 times x to the 4th. What's 12 divided by 3? 4. So 3 to the 4th times x to the 4th. What's 3 to the 4th? Well, 3 times 3 is 9. Times 3, 27. Times 3, 81. So that would be 81 x to the 4th. And that's our final answer. So you can see when you start to get like a power in here and then a root out here, if you make it into a fraction, you look for the denominator, that basic, we're looking for 3 numbers multiplied together. Once you get that, then these two cancel out and you're left with that 4. 3 to the 4th, which when you multiply it out is 81 x to the 4th. And that's basically how you simplify that. When you start to get more complex simplification, it's way better to use this method. So those are 3 examples. I'd like to show you one more, which is actually a little easier, I think, than this, but it just kind of sets people off because instead of just one square root, you have a few of them. So let's move and turn the page, and we get our last example here, which is the square root of 2x times the square root of 14x cubed times the square root of 5x. Same as this one here. When we have separate ones and they have the same base and the same power, we're going to put them together and we're going to put them all under one square root. So let's do that. This is square root 2x times 14x cubed times 5x. Another way to write that is, okay, 2x times 14x cubed times 5x to the 1/2 power. And that looks kind of messy. Let me see if I can fix that a little bit. Let me write it over here. So 2x times 14x cubed times 5x to the 1/2 power. All right. There is no root here. It's assumed it's a base 2. The fraction will be 2 in the denominator, and none of them have powers except for x cubed, which I've written here. And so I just leave it like that. Now I'm going to assign a power for each one so I don't mess this up. 1, 1, 1, 1, just as a reminder. 1, 1, 1. Now I'm going to distribute this through. Okay? I can do that, or I can multiply the numbers, right? And then kind of see. So I'm going to try and simplify this first. I could distribute it out, and eventually I'll get to the answer. But I'm going to put this together and see how many pairs of numbers that are multiplied together work out, and we'll be able to simplify with that. So let's see. I have 2, 14, and I have 5. Okay, let me put those together. 2, 14, and 5 times x cubed, and x, all to the 1/2 power. Okay, so let me look at 2, 14, and 5. 2 is a prime number, so you're done. 14, let me use a factor tree color. 14 is 2 times 7. And 5 is a factor. So let me simplify that. 2 times 2 times 7, right? Let me do this. I'll do this underline so you can see it. 14 is 2 times 7. And 5, let me do this, times 5 is 5. Now we have times x, 1, 1, 1, 2, 3, 4, 5, x to the 5th. Okay, to the 1/2 power. All right, so do I have any numbers, right? Let's say I have 2 squared, and then I have 35, right? Okay. So I have 2 squared, times 7 times 5. X to the 5 over 2. And I multiply it, right? X to the 5th. Sorry, I'm not quite there yet. I'm getting there. Now we're going to multiply this out. And we get 2 times 1/2, which is 2 to the 1. All right. 7, 1 times 1/2, 7 to the 1/2. 5, 1 times 1/2, 5 to the 1/2. And X, 5 times 1/2, which is 5 over 2. Okay? All right. So that is 2. Answer. Now these two are still to the 1/2. We can call that 35 to the 1/2 because we can multiply the two. Different bases, yes, but they're in the same power, so we can multiply those two together. Okay? X to the 5 over 2. Okay. Well, we get, how many groups of 2 do I have when I have x to the 5th power? Let me make a little factor tree with that. X to the 5th is 1, 2, 3, 4, 5. A group of 2, a group of 2. I got 2 groups of 2. That is, okay, x times x, and then I have a little extra one, right? And that is x to the 1/2. So what are my 1/2s? And what are my just no power there? So I have a 2, I have an x, and I have an x. Okay, those are going to go in front. 2x squared. Now what am I have left with the 1/2 power? I have 35 to the 1/2 and x to the 1/2. So I'm going to write this 35x to the 1/2. And if you want to see it as a radical, it would look something like this. Final answer. 2x squared, square root 35x. And you're done. Seems like a lot of work. I've showed you every single minute step. We decided to multiply these out, right? And I put them as basic as possible. I could have put this x to the 5th as x squared or x to the 4th. X squared times x squared times 1. That would have simplified it out a little bit better. But if for whatever reason you don't do it, well, you say, okay, 5 divided by 2. When I look at my x to the 5th, I have 5 of them, and that's 2 groups, 2 pairs of x squares. Okay, so this is basically another example. There's different ways to approach this. I went one way. It may have been, could have worked out a little differently, but give it a shot, practice, and as you're doing your problems, you know, you'll get a little bit better at it. So good luck, and I guess we'll keep posting. So have a good one.